Hello everybody, getting ready to do classwork lesson 7.7, pre-calculus math today, classwork lesson for that. And for today's lesson, you will have 8 points in your notebook. Guide students, have that out. And then 20 points on your classwork sheet, have your classwork sheet out for that. Part 2, 7.7, the determinant of a square matrix. And today's bell work, students, teachers, here's today's bell work. Solve the system of equations using the method of substitution or the method of elimination for these two systems here. Give your students 5 minutes. See you in 5 minutes. Okay, welcome back for the solutions for today's bell work. And for this system here, we end up with y equals negative x minus 2. And then 3x minus 10 times quantity negative x minus 2 for y. We plug that in here and 10 times that, and we end up with x equals 2 for that. So our answer is 2, negative 4 for our solutions there. And then down here for this system, this will go 2x plus y equals 2, y equals 2 minus 2x. Then we plug that in up here, and we get 5x plus 7 times 2 minus 2x. We solve for x, and we get x equals negative 1, and then y equals 2 minus 1 equals 4. So our solution for this system here is negative 1 and 4. Now into our lesson today. Into your notebook, students, the determinant of a square matrix. The following definition is called inductive because it uses determinants of matrices of dimension n minus 1 times n minus 1 to define determinants of matrices of dimension n times n. The determinant of a square matrix, if A is a square matrix of dimension 2 by 2 or greater, then the determinant of A is the sum of the entries in any row, or column of A multiplied by their respective cofactors. For instance, expanding along the first row yields the determinant of A equals A11 C11 plus A12 C12 plus A1n times C1n. So this is a way to find the determinant of a square matrix. Let's get into an example of that. Applying this definition to find a determinant is called expanding by cofactors. Okay, so try checking that for a 2 by 2 matrix. So in this situation here, this is a 2 by 2, A1B1, A2B2. This definition of the determinant yields the determinant of A equals A1B2 minus A2B1 as defined. So we've already defined that. So the determinant of a matrix of dimension 3 by 3. So find the determinant of this 3 by 3 here. Note that this is the same matrix that was in example 2. There you found the cofactors of the entries in the first row to be negative 1, 5, and 4 for the first row up here, first row expansion. So now 0 times negative 1 plus 2 times 5 plus 1 times 4 will equal 14. Find the determinant of this matrix is here. Expand by cofactors on the row or column that appears to make the computations easiest. So we need to figure that one out here. So expand along column 3. So column 3 is over here. We have a 0 here, so that makes it easiest. So we can expand from that, from column 3. And then this will equal negative 2 times 3, 2, and then negative 1, 4. So we'll block that out, block this out, plus 3 times 1, 4, and then 3, 2 up here as well. And once we do that, we have negative 2 times 14. See, 3 times 4 is 12, minus 2 is 14. And then 3 times here would be negative 10. It would be 1 times 2 plus 3 times 4 minus, wait a minute here, 1 times 2 minus 3 times 4 would be negative 10. And then when you add these together, you get negative 58 for that. And then down here, you can expand here along column 3 because this has the most zeros here. So when we do that, we have 0 times 7, 2, 111, minus 0 times negative 3, 0, 7, 11. And when we do that, we have 2 times negative 33 will equal negative 66 for this matrix here. In example 3, the determinant was found by expanding by the cofactors in the first row. You could have used any row or column. For instance, you could have expanded along the second row to obtain, so the determinant of A would equal A21 C21 plus A22 C22 plus A23 C23. This would be second row expansion there. And that would equal 3 times the negative 2 plus negative 1 times negative 4 plus 2 times 8 would equal 14. And when expanding by cofactors, you do not need to find cofactors of 0 entries. Just keep that in mind because 0 times its cofactor is going to be 0. Okay, further into your notebook, Aij, Cij equals 0 times Cij will equal 0. So that proves that. So the row or column containing the most zeros is usually the best choice. So we got 0 here. Is usually the best choice for expansion by cofactors. And that is your 7.7 Part 2 classwork. And if you need solution PowerPoints, classwork sheets, homework sheets, or any other course materials, my email is animatedpowerpointmathvideo@aol.com. Thank you very much.